Hello friends, today's question. A block of mass 5 kg, in first case pushed in case 1 and second pulled in case B by a force F 20 Newton, making an angle of 30 with the horizontal as shown in figures. The coefficient of friction between the block and the floor is 0.2. The difference between the acceleration of the block in case B and the case A will be. So we have two cases A and B. In the first case it is being pushed and the second case it is being pulled, and we are supposed to find out what will be the acceleration of difference in the acceleration A and B. Okay. So let us consider case 1, a case A, and draw the free body diagram for it. Case A. So it is being pulled with a force of 20 Newton, which is making an angle of 30 with the horizontal. Now this force F can be divided into two components. This will be our F sine of 30 and this will be F cos of 30, and the other force which will be acting in the downward direction will be the mg, and there will be normal, let us suppose that is n1, and there is a friction. So we say let this block will be moving towards the right side with the acceleration of a1, or let us go, and the friction is Fr in the opposite direction. So you can write the equation for the forces in the vertical as well as in the horizontal direction. Okay. So you can say for vertical direction, two forces are acting downward, mg and f sine theta, and one is acting upward, that is n1. So from here we can say that our n1 will be equal to mg plus f sine of 30, and n1 m is our 5 kg, g is 10, and force applied is 20 Newton, and this is 1 by 2. So from here I can say that this and this goes away, so we are left with that N1 is equal to 60 Newton. And now the equation in the horizontal direction, so you can say for horizontal direction, it is moving with the acceleration of a1, so we get our ma1 will be equal to applied force, that is F cos of 30, minus frictional force, that is Fr, let us call this Fr1, and we can find out our Fr1. Fr1 will be equal to mu into n1, and mu is 0.2 and n1 is of 60, so from here we get that Fr1 will be equal to our 12 Newton. Therefore the acceleration a1 will be equal to F is 20 multiplied by cos of 30 minus Fr1 is 12 and divided by 5. So from here you can say that the acceleration a1 will be equal to 1.064 meter per second square. So this is for case A. Similarly, we can solve for the case B or case B. Now it is being pulled with the force which is same, that F is equal to 20 Newton, making the same angle 30. So here it can be divided into two components now. This will be F sine of 30 and this will be F cos of 30. In the downward direction we are going to have mg, and there will be the normal. Let us suppose that normal is N2, and the frictional force, let us call that FR2, and in this case we assume that it is moving towards the right with the acceleration of A2. So we can write once again for vertical direction, we get, now downward is only one force, that is mg. Upward we have 2 N2 and F sine theta. So you can say that N2 plus F sine of 30 is equal to mg, and from here we can write that our N2 will be equal to mg minus F sine of 30. Therefore we get that N2, M is over 5, G is 10, and applied force is 20. This is 1 by 2. So from here we get that our N2 will be equal to, this goes by 10, and so we get that N2 will be equal to 40 Newton. So now if the body, this was in vertical direction, and for, we can say for horizontal direction, the acceleration is A2 towards the right. So we can write the equation as ma2 is equal to F cos of 30 minus FR2, and we can calculate of FR2 is equal to mu into N2. Mu is 0.2, N2 is 40, so we get that FR2 is equal to 8 Newton. So here we can say A2, F is our 20 cos of 30 minus 8 divided by 5. So we get this as A2 will be equal to 1.86064 rather meter per second square. Now we have two accelerations. This is in the first case and this is for the second case, and we have to find out the difference in the acceleration. So you can say difference in acceleration will be equal to A2 minus A1, so which is 1.864 minus 1.064. So we can say that A difference will be equal to, this will be coming as 0.08 meter per second square. So this is the difference in acceleration in case B and case A. This is difference in acceleration in case B and case A. This completes the question. Thank you.